This is my abstract. I wasn't sure how long I would be speaking today. This could be a dissertation. I will not cover all of this since I've got about 20 minutes, but this was what I was interested in when we were originally investigating it. And this is kind of what I'm getting into right now. I'll jump forward because you're going to get these slides in about a week anyways. I am working a lot with aluminum castings and new aluminum alloys. And what I am seeing from my customers is that, of course, we're seeing a tremendous amount of use of aluminum in the industry. Lightweighting, we've heard of it. Sure, there was a big push with it for EV. Of course, that's kind of taking a little bit of a backseat, but hybrid is getting more of a push, which still has batteries in it. Still ICE, we want to get as much mileage out of our vehicles as possible, which lends towards using aluminum. So we can displace some of that weight, get better mileage. And also, regardless, we all have sustainability goals, and aluminum is practically 100% recyclable. So it works well for everyone. Anytime we add alloys, it's going to make surface treatment a little bit more challenging for my side. And we are seeing a lot of new, I'm working with OEMs and aluminum manufacturers, and they are sending me aluminum samples to work with. These are typically under NDAs. I don't necessarily know what I'm using, what I'm working with, and they're still expecting to get certain performance. Great. I love playing around with it, seeing what I can do in the lab. And it's interesting to see how these perform, how they take on a coating. And we are always seeing, for good, that performance requirements from our customers are getting more rigorous. It's great for the end customer, makes life a little more challenging for us. Not necessarily a bad thing. These are some specific alloys, casting alloys that will look very familiar to you, that we work with all the time. But like the A356 is a structural alloy. The 6000 series, we see that a lot in the automotive industry. Great for machinability and strong. 7000 series is highly used for aerospace, but also used for the battery casings. Now, what you might also be hearing about a lot is gigapresses, and how gigapresses are offsetting huge numbers of parts. There are certain gigapresses that have removed entire cases, entire sections of vehicles. For the Model Y, 1 gigacasting replaces 70 underbody parts. For the Model 3, it's 171 parts. And for every part that you replace, you are probably also replacing 4 welds. So this is something that will be done in the future. Granted, this is a huge upfront cost, but this moves, this is going to move our manufacturing speed forward. It's going to reduce complexity, man hours. Granted, we saw orders of these gigacastings that were coming in, that were being installed throughout North America. I'm not quite sure, I haven't been following it for the last few weeks, but my understanding is they're still being installed, they're still coming in, and they are causing a particular challenge for me, because with these gigacastings, they tend to be stickier metals. And these stickier metals can be more challenging to remove their mold release agents. So you need to use a stronger mold release agent to get it out of the mold. So now I have to remove that mold release agent. And I don't necessarily know what that mold release agent is. And I don't necessarily know what that alloy is anymore. So what I'm finding is I really need a good etch and cleaner. And aluminum alloys are, aluminum is amphoteric. So it'll dissolve at higher pHs and at lower pHs. So the nice thing about that is that I can get etch at higher pHs or at lower pHs. So at the beginning of our process, I'm finding I can't get away with a low pH cleaner. I need to etch those parts. So, but anybody that's played around with aluminum at all knows you can't smut it either. So we're running kind of a fine line there. And thankfully we have labs and we run, our customers send us parts and we run them and we dial it in and we figure out how well it's going to run and we kind of tune it up before we actually run it on their line. Now, of course, the alloy probably is going to change a little bit before we actually run it on their line. So then we show up on the line and we tune it up all over again. And that just keeps things interesting, right? Now, then we move on to the acid deoxidizers. This is very important. So we have a shock tower here with all different profiles and all different levels of oxidation. So now for acid deoxidizers, we're going to be removing the aluminum oxide layer. Now, that aluminum oxide layer is a pain because if you don't remove that and you glue it or put paint on it or put a weld on it, that aluminum oxide layer is very brittle and it will just fail. So you've wasted time. It looks bad, and it could be a safety issue. So we have to remove that aluminum oxide layer. So we have to deoxidize it in some manner, either with an etch passivation, which is a process we have, or with an independent acid deoxidizer. So, and look at my timing. I don't want to, like I said, I do not want to get in the way of the bar. I'm being careful. So acid deoxidizers work very well because they can also neutralize any residual alkalinity that's coming in from the system as well. They remove that that oxide layer, and they can give you a nice uniform surface. So they can, if you had any brush marks, or like I said, with those castings and how they can be sticky and they can be hard to remove from some of those presses, sometimes we're seeing where people are kind of having to jam them out of the presses and they're getting some lines. The acid deoxidizers can actually clean some of that up and even up that and create a uniform surface. These surfaces also, prior to being deoxidized, also have quite a bit of resistivity on them. And that becomes an issue if you are working with electronics or in the EV. So the use of deoxidizers for coating formation, regardless of the alloy. So we have 2000 series, 6000 series, 7000 series alloys. The blue is no deoxidizer, red is deoxidizer. And on the left is coating weights. So as you can see, if you don't use a deoxidizer, you pretty predictably get at least half of what you would get with deoxidation. So we only have a limited time in these systems. If your throughput is a problem, if you're ramping up production and you need to get more parts, more capacity through your systems, this becomes an issue if you're not hitting your coating weights. And you need to dial in your deoxidizer and make sure that you've removed that surface so that your conversion coating isn't doing the work of your deoxidizer. Because my conversion coatings, being I work with aluminum a lot, are acidic and will do a bit of etching. Now, talking about the effects of deoxidizers on resistivity, when you look at this slide, I want you to think about your market and the ability to expand the use of aluminum versus maybe copper. Now, copper has very low resistivity and is used extensively in electronics and the EV industry. But we can bring that resistivity all the way down if we etch it well and then seal up that aluminum with a very light passivation coating. So this allows us to do more with aluminum if we etch properly. And this isn't the greatest slide. On the left-hand side is low etch. On the right-hand side is a high etch. So, but you can see, if you look at resistivity, this is the question I get from customers when they're like, I'm working with batteries. Can you get down to under 20 microohms? Yes. But that's tight. And that's with a conversion coating, because as soon as you remove that aluminum oxide coating, aluminum wants to put that oxide layer right back on. So I need to seal up that coating immediately. I need to get it rinsed and get it passivated right away. Because if it hangs out, it's just going to put another aluminum oxide layer right back on. So no line stoppages. On the top here is a classic light metal pretreatment process. And this is what I've been working on for the last couple of years. Light metal pretreatment process, classic cleaner, and depending on your water, you can use city water. Then we would use an etching or a deox stage. The terms are used kind of interchangeably there. Rinse, then a DI rinse before your passivation stage, or also known as conversion coating stage. And we use that DI water there because we don't want to drag any additional contaminants into our passivation stage, because honestly, that passivation stage is built up at maybe 1.5%, 2% chemistry. So you don't want to drag any contaminants into it. It's just keep it as clean as possible. It'll last you as long as possible. You're better. And when I say DI rinse, just like David said, DI or RO water. And then we follow it up with a couple of good rinses and then force air dry it and send it on its way. Now, what I've been working a lot with lately, last couple of years, is the etch passivation process. This was developed out of Europe for a customer of ours that was having issues with battery trays. They had suppliers, and I work more on the component side. So they had component suppliers that were making battery trays for them. So they're making them in one place, and then they are manufacturing these battery trays, and they have to move them to the assembly location. So these battery trays were having problems with losing seal. And you don't want your battery tray to lose seal. You don't want to get contaminants in water and all that other nasty stuff in your battery tray. So we worked with them, created this process. And the nice thing is we were able to shrink down the process. So we have a smaller footprint. We've actually reduced 2 stages or 2 tanks at least. So you have less manpower, less water treatment. Oh, and I should say the etch passivation is at room temperature. So assuming room temperature is around, or ambient, so it's around 70, 80 degrees, depending on, usually you've got some relatively good sized parts running through here, and they will usually carry some heat through there. But we try to keep it, if it isn't 60 degrees, you're doing all right. But as we all know, time, temperature, and concentration, if your temperature starts going up, you're going to drive that reaction a little bit faster. And so you're going to end up with more coating. So we want to keep that temperature relatively the same. But we were able to combine these and shorten up the footprint. And so now we have cleaner, rinse, DI rinse prior to this etch passivation stage, and then follow it with the DI rinses. And these are standalone products that cleaner is a 1-part cleaner. The etch passivation is a 1-part product. There isn't a makeup and a replenisher. So it's pretty easy to control. This is the product. Now, I know we don't want to really get into products and all that, but it's titanium fluoride based. It is aluminum only. It is mainly for immersion, but it can also be done in a spray application. However, the coating weights will get higher in a spray application, so we got to tweak it a little bit if you run it spray. It does run on a low pH side. The temporary passivation coating, it's good for 4 to 12 weeks, depending on final storage conditions. You cannot store this right next to your tank. It needs to be clean, dry, covered, and low humidity. We do have one supplier that has it really dialed in, and they can store it for 6 months, but they have it very dialed in. And I do not tell people that they can do it for 6 months, because they even have specialized packaging that they put everything in and then they store it. But you can definitely process your part, package it up, and then put it on your truck and get it to the final operating spot where they can do their welding and adhesive, put in their gaskets, and paint it up. It's a great base for bonding and simultaneous etching and conversion. Now, we were talking about, I actually have a picture of the XRF gun. I got so excited when you said an XRF gun. It's amazing what people get excited about. This is how you control it, because it is aluminum, and these are coating weights are 1 to 15 milligrams per meter squared. You can't see this coating. I mean, it's like just a little bit of something. And so we have to measure it with an XRF gun. And the XRF gun has to be calibrated with titanium standards that we recommend. You get the titanium standards from Micromatter in British Columbia, and you calibrate it every day, or else your supplier won't be very happy with you, or your customer won't be very happy with you, because our customers, the OEM suppliers that we do this for, are pretty specific that you document that you are getting this dialed in coating weight. Because if you get too high of a coating weight, they are concerned about welding interrupting. And that is one of the reasons why they want the lower coating weights. Now, this product does not have the additional polymers in it that can interrupt your welding. We do have other products that if you need more corrosion protection, you can add zirconium and polymers and build up your coating weights. But this is primarily for a transportation coating, just to get you from point A to point B. And at Henkel, we have all kinds of toys, all the different XRF guns and XRF units to check it out. I do not travel with an XRF gun because people don't like it when you cross state lines with them. But I did get titanium standards. So my customers that have XRF guns, I can go there and check their equipment and make sure that their equipment is calibrated correctly. So summary and key takeaways, we're seeing more aluminum parts coming into the market. The new alloys are more challenging. I no longer say, oh, just use this cleaner. Oh, just use this. Oh, just use that. We do cleaning studies. We double check. When we go in the field, we're ready, because we're ready to tweak it. And we know that there are going to be changes, because it's getting a little bit more challenging out there with the new alloys. The etch passivation process works very nicely for aluminum components that are going to be glued, welded, or painted after treatment. It stabilizes the surface. As I said, that the one thing, if I leave you with good to know, is that that aluminum oxide coating, as soon as you remove it, it will come right back if you do not stabilize that surface immediately. So this product, that Bonderite MNT 2040 R2, is also used on aluminum wheel lines particularly for people that have issues with like line stoppages, because if you have a line stoppage in an aluminum wheel line, you can end up, after you've deoxidized that wheel, you would want that protection, that little bit of titanium coating to protect that wheel before it hits the other conversion coating stage. So it's used in other applications to protect aluminum. But do you have any questions? Thank you.
Okay, thank you. Do we have any questions in the room? I have questions in the app, so I'll get started. And if anybody has any questions, they can raise their hands. So let me rephrase this. So how detrimental is the etch material to the bath efficiency, and how do you most effectively remove the etch material from the bath?
We use filters. We can use that 5 to, depending on, we can use a 5 micron filter to etch it. We do actually build up a certain amount of aluminum in the bath. It helps drive the reaction. But once you hit a certain threshold with the bath, then, like I said, it's also built up at 1.5 to 2%. So how much are you fighting it, right? You might want to dump and recharge it also. Or you might hit a steady state where you are carrying out as much and you're just rebuilding the bath. But we do build up. Aluminum is one of the things that we do monitor. And so it helps drive the reaction. So did that make sense?
Aluminum castings, are they pure aluminum alloys or blends, especially for giga castings?
They're blends, yeah. Okay. Pure aluminum has very low resistivity, but which is great for like an electronic application, but the strength is very low. So you need to alloy it to get some strength.
What solution is used for etching and for passivation? And there's a second part to this. And what solution is used when the combined stage of etch passivation?
Oh, standalone etching and passivation. Okay, if it's standalone, we would use maybe an acid deoxidizer that would be like a Bondrite CIC HX357 would be our standard deoxidizer. So that would, but like I said, we test. First qualify. So we do have a number of deoxidizers that we would use, and then we could follow that up with rinses. And then we have other conversion coatings as well if you wanted higher coating weights for more corrosion protection. So it's all really what your customer's requirements are. So we had such a short period of time here. I apologize. We could probably, I usually spend 8 hours training on this. So.
Any analysis on the composition of passivation layer? How much is aluminum oxide in the passivated layer?
How much is the aluminum?
Aluminum oxide in the passivation layer. So once the passivation is complete.
How much is no, we've removed the aluminum oxide.
Right. So
it is an aluminum, it's a titanium oxide coating.
Okay. What is the coating formation mechanism? pH driven or metal contamination? Or doping?
It's pH. But it does have some aluminum helps drive the reaction as well. But yeah, they're probably asking if there's like how there's zinc in the bath as well. So we have for a zinc phosphate bath. But with this application, there is titanium it's a titanium oxide coating that uses some of the aluminum that's in the bath to help drive the reaction. So we actually, to control coating weights, a lot of it is done by hang time. So we immerse the part and then it's almost the opposite of like the thin film coatings. It doesn't really matter how long it's in the bath, it's how long it has to process outside of the tank, and it can hang, and that's when it's building. And then we actually rinse it.
Which process is more efficient or preferred to remove the surface oxide from casting process? Degreaser or acid pickling?
Well, they both do different things, honestly. So your alkaline is going to remove most of your organic soils, and your acid's going to remove more of your inorganic soils. So you kind of need both. But I do like, particularly with what I'm running into with the new alloys, I do like to have that nice etching alkaline cleaner to get a bite into the surface. I'm finding that I can't use lighter. Yeah, it's just not working out for me. I need a bite.
I don't know if I asked this. Is the etch passivation process just for component lines?
Oh, it's only for aluminum lines. So in theory, if you had 100% aluminum anything, you could use it for, as long as you were just using it for that a light titanium oxide coating. Yeah. And you had your manage expectations that you were looking for very light short-term passivation for bonding, paint adhesion, and welding. So it's
Last two questions. This question has two components, so I'll do the easy one.
okay.
How does a surface treatment supplier provide a robust cleaner even when the casting is run on a mixed metal line?
Well, for a casting,
Yes.
okay. Well, a lot of times we usually have two tanks. A lot of our customers, I'm not going to ruin it. I'm not going to, especially with an immersion. I work with a lot of jobbers, and I am not going to threaten shutting them down by stopping production, by having some really bad castings. I've just seen it happen so close so many times that if they get some bad castings and they don't know what's coming in on them, that they could shut down their operation. So I don't know if that really answers the question, but I will have, just from running a business standpoint, I would have two cleaners.
The first component of this question was casting plus dye release agent plus quenching agent as cast surface or machine surface, or to be used for surface bonding. I don't know if it makes sense, but I can repeat it.
Yeah, say it again.
So casting, dye release agent, quenching agent as cast surface or machine surface, or to be used for surface bonding. I don't know who had this question. Maybe they can rephrase.
All of the things that are stacked against you.
Yeah.
You've got as cast, it's machined.
Oh, yeah.
And you're trying to, this needs to have bonding, this you don't care. I'm just kind of getting at, how do you balance a cleaning system for a giga casting that's going to have multiple surfaces and multiple functions, and yet you've got to go through a system.
Cleaning system. What we have seen is a lot of these systems are run initially through jobbers, because typically the bigger guys, they don't want to put in these lines until they don't want to take the risk, right? So they're not going to put the money in, and they're going to, until it's fully ramped up, they're going to run it through the jobbers. So what we're doing is I typically recommend like 2 cleaners, and you can have, because I have seen castings, people get in some really nasty castings that almost shut down their lines, and I'm like, just don't do it. And I've even had where there were 2 2040 tanks, one for the rough extrusions, or one for the rough castings, and one for the extrusions, because they will react differently. And especially when you have those tight, those kind of really, really tight coating weight requirements, you can save yourself a lot of headache. And really, there aren't that many steps. There aren't that many tanks with this system. So a lot of times people can just say, oh, well, I've already got those tanks because we've adapted. We have the etch passivation, so we already have these extra tanks anyways. So we've been lucky in that regard that we've been able to convert that way.
Down to the last question. Can the Bondrite MNT2540 also be used on aluminum extrusions for bonding purposes?
Yes, yeah.
Okay.
Yep.
It's 2-0.
Two, yeah,
Oh, okay.
yeah, yeah.
Okay.
No, that's all right. I knew it. That's all right. That's all right. Yes.
Okay.
Chris, is this Henkel Day?
Yeah, no, it's good. It's good. Keeping us loose.
Okay, so that is the end of questions on the app. If there are any other questions in the room, this is your time to ask those. If not, a big round of applause.
Oh, thank you.
Thank you
for
very
the
much.
opportunity. Thank you, Arthur.